Hi, today we're going to talk about right angles in geometric figures. So let's focus on the left side of our notes here. So you have different kind of triangles. We are going to focus on isosceles and equilateral triangles. So anytime you have an isosceles or equilateral triangle, if you draw your altitude or your height inside of the triangle, you will see that the height of that triangle will actually intersect the base of that triangle in the middle, and it will intersect at a 90-degree angle. So if we look at example number one, it says find the missing length here. So we have this triangle, and we have that the triangle has two sides with one tick mark each. That means that they are worth the same amount. So I'm going to put that as X here on the other side. We should already know from the diagram on the left that the height goes down the middle and it intersects at a right angle there. So one thing that I do know is that if the entire base is 9 inches, then I know that the base of half of it is going to be 4.5 inches. So now I need to look at the information that is presented on the left triangle to figure out which trig ratio I can use. So from here, I can say that we are given, if we look at the 72 degrees, we have our adjacent, which is the 4.5, and we have our hypotenuse, which is x, because x is across from the 90-degree angle. So if we have adjacent and hypotenuse, we're going to use cosine. So here we can say that the cosine of 72 is equal to 4.5 over the hypotenuse x. So I'm going to multiply both sides by x, which is going to give me cosine of 72 is equal to 4.5. And then I'm going to divide both sides by cosine of 72. So I'm going to have x is equal to 4.5 divided by cosine of 72. So remember, make sure your calculator is in degree mode. So when I do 4.5 divided by cosine of 72, I end up with x being approximately 14.6 inches in 3 sig fig. All right. So if we look at number two, we are still dealing with an isosceles triangle. So remember, if you draw your height, it goes from the middle all the way down to the bottom. So we can tell here that this is a 90-degree triangle, and just like the height or the altitude cuts the base in half, it is also going to cut the angle in half as well. So here we have a triangle. So what we're going to do is we're going to find the angle, and I'm going to call this angle X for right now in the half of the triangle. And the missing angle that we want to find is that Greek letter which we call beta. So this angle here is the Greek symbol called beta. So I know that beta is going to be 2 times x degrees. So if I focus on the x degrees and the information presented to me, I already know that the base of this triangle, which is 3.95, I would have to divide that in half. So that is going to give me 1.975 as the base of that right triangle on the right. So I can set up my trig ratio for the angle x. So if I look, the 1.975 is my opposite, and the 7.82 is going to be my hypotenuse. So I'm going to be dealing with sine here. So I'm going to have sine of angle x is going to be equal to 1.975 over 7.82. And I know that I'm going to have to find the sine inverse. So I know that x is going to be equal to the sine inverse of 1.975 over 7.82. So once I do that, I can let the calculator take care of that. So I take the sine inverse, 1.975 divided by 7.82. And I end up getting that my angle is going to be approximately 14.6 degrees. Now you have to keep in mind that the angle beta was 2 times that amount. All right, so beta is going to be equal to 2 times 14.6 degrees. And if we do 14.6 times 2, we end up getting 29.2 degrees. That will be our beta. All right, so that will be our answer here for number 2. All right, for number 3, we are talking about a rectangle. So I did not put any information on our notes about a rectangle because you should understand that a rectangle has 2 sets of sides that are opposite of each other, and they should be the same measure or congruent, and the sides do intersect to form 90-degree angles. So it says the diagonal of the shorter side of a rectangle can make an angle of 62.9 degrees. So if we look here, we're going to draw it out. So if we have a rectangle, it says the diagonal and the shorter side. So the diagonal and the shorter side is going to make an angle of 62.9 degrees. We already know that this is a 90-degree angle here, a 90-degree angle here. This can also be looked at as 62.9 degrees as well. It says if the longer side is 12.6 centimeters, find the length of the longer side. Or excuse me, it should be find the length of the shorter side. Okay, so make that correction there. So if we wanted to find that information, you would just need to make sure you label it. Anytime they give you a picture or a word words about a shape, it's always easier to draw it out and label it. Always. Okay, it's always easier to draw it out and label it. So if we have our information here, then we know that we can label the longer side as 12.6. And it doesn't matter which side that you label 12.6. Both of them or one of them does not matter. So I'm only going to focus on one side or one triangle in the rectangle. So I'm going to focus on the bottom triangle. So the bottom triangle, if I use my 62.9 degrees, I'm looking for the shorter side, which is X here, and I'm giving the adjacent. So I have the opposite and the adjacent, so that's going to be the tangent. So here I can say the tangent of 62.9 degrees is equal to the opposite, which is X, divided by 12.6. So I need to multiply both sides by 12.6. So that's going to give me 12.6 times the tangent of 62.9. And then I know that if I do 12.6 times the tangent of 62.9 in the calculator, remember, make sure your calculator is in degree mode, then I know that this is going to be approximately 24.6, and we know that we are talking about centimeters. That is what X is going to be approximately. All right, so that is my answer for example 3. If I look at example number 4, and before we get to example number 4, let's go back to the front page where it is talking about you have a rhombus and a square. So anytime you have a rhombus and a square, you need to realize that all sides are going to be the same, but you also need to understand that whether you're dealing with a rhombus or a square, that the diagonals intersect at 90-degree angles. All right, so example number 4 states the diagonals of a rhombus has the lengths of 7 and 12 meters. Find the larger angle of the rhombus. So I'm going to just sketch out a rhombus. A rhombus looks like a parallelogram, except the sides are the same. It doesn't have to be perfect. All right, so it says it has the diagonals of the length 7 and 12. So I already know that here, this diagonal is going to be the shorter one, and that's going to be 7. And then I'm going to have my diagonal here, which is going to be 12. And I'm going to go ahead and put my 90-degree angle in here. So if I know that the shorter diagonal is 7, then that means that each side of the shorter diagonal is going to be 3.5. And I know that the larger diagonal is 12, which means that the half of it is going to be 6 and 6. So what I'm going to use is I'm going to use just one part or one triangle. So I'm going to use the part of my triangle that is lying in this region right here. Okay, because I still know that I have a 90-degree angle here, and then I can just use the information to find what I need. So when you are looking at the larger angle, one thing you need to understand is that when you are, a diagonal is literally cutting those angles in half. So if I want to, and I'm going to just bring this out a little bit so I can write on it a little bit better. So if I know that this is my angle and I know that this is 3.5 and this is 6, then I want to find this angle here, and I'm going to call it angle X. So in order for me to do that, what I'm going to end up having to do is I have to understand that I have the opposite and the adjacent of X. So I'm going to be using tan. So I'm going to have the tangent of X is equal to 6 divided by 3.5. So I already know that X is going to be equal to the tangent inverse of 6 over 3.5. So when I find the tangent inverse of 6 divided by 3.5, I end up getting that X is approximately 59.7 degrees. And I know that the larger angle, anytime it says find the larger angle, what it's wanting me to do is it's asking me to find this whole angle here. So I already know that that large angle will be equal to 2 times that amount. So I'm going to label this angle L. So I can basically say that the larger angle is going to be equal to 59.7 times 2, which gives me 119 0.4 degrees. That is my larger angle. And that'll be my answer there. All right, so now let's look at example number 5. So here we have a trapezoid. Okay, so anytime you have a trapezoid is nothing but a rectangle with two triangles on the side of it. That's the way you need to think about it. It is what we call a composite figure. So if we want to find the missing side length, or x, one thing that you need to understand when dealing with a trapezoid is that your heights are the same no matter where you draw it from. So the first thing that I need to do in order to find x is I need to find the length of my heights. So I'm going to use this right triangle on the right hand side because I know that this is a 90-degree angle here. So I'm going to see that, okay, I'm going to call this side length y for right now. So I have the angle 51, I have the opposite, which is y, and then I have the hypotenuse, which is 4.5. So I'm going to be using sine. So here I'm going to say that the sine of 51 is equal to y divided by 4.5. And I'm going to multiply both sides by 4.5. So 4.5 times the sine of 51 is equal to y. So if I do 4.5 times the sine of 51 in the calculator, I end up getting that y is approximately 3.5 in 3 sig fig. And we know that that's about 3.5, and we know that the units that we have is centimeters. So now that I know that that's 3.5 centimeters, I can then say, instead of writing y, I can focus on just writing in the number 3.5 here. And if I write it there, I can write it on the left side as well because the heights are the same. So now I'm going to deal with the triangle on the left. And if I'm given the angle 68, keep in mind that I already know that this is a 90-degree angle here. If I look at the angle 68, I'm having the opposite and the hypotenuse again, so I'm going to be using sine for that one as well. So what I'm going to end up having is the sine of 68 is going to be equal to 3.5 over x, because opposite over hypotenuse. So I'm going to multiply both sides by x, and then I'm going to divide both sides by sine of 68. So once I do that, all I have to do is just simplify. So if I have 3.5 divided by sine of 68, I will end up with x being approximately 3.77. And we know that that is going to be the units of centimeters. All right. So let's look at example number 6. So before we get into example number 6, if we direct our attention to the left-hand side, we see that anytime you have a tangent to a circle, remember, a tangent is a line that touches the side of a circle at a point, and we already know that the center to the edge of a circle is the radius. So we should already know that a tangent line and the radius can intersect at 90-degree angles. You should understand that the angle inside of a semicircle is always a 90-degree angle, meaning that if I have a semicircle, if I create a triangle within it, that chord and that chord create 90-degree angles there. That is a property. And then it has here, for the last property of a circle, is that anytime you have a line that is drawn from a center of a circle at 90 degrees and you draw it to a chord, our chord is what's highlighted here. Anytime you draw a line from the center of your circle and it touches that chord, it's going to intersect at 90 degrees as well as cut that chord into two equal pieces. So we're going to use these properties to solve questions like number 6. So it says a chord of a circle subtends an angle of 134 degrees at its center. So what that means is if I draw a circle here, and it may not be exact, but it'll be fine. So if I have this circle here, I already know that the center is going to be somewhere here, and it may not be exact because this is a drawing. It says it subtends an angle of 134 degrees. So I already know that half of that is 180, so 134 is going to be approximately something like this. Okay, so if I know that that's 134 degrees there, it is saying that the circle has a radius of 5.25, and we want to find the length of the chord. So if we want to find, and I'm going to redraw this a little bit just to make it a little neater. If we want to find the length of the chord, we need to understand that the length of the chord is going to be here. So I want to find this x here. We already know that this angle is already 134 degrees. And we should also remember that this line is going to intersect at 90 degrees here. And it says that the circle has a radius of 5.5. So if we want to find the length of the chord, what is going to end up happening is that we're going to label our radius, which, remember, your radius is always from the center to the edge. So I'm going to label this as 5.25. And from there, I can say that I have a right triangle in this area. And this is going to be 5.25. And then if I take 134 and I divide it by 2, that means that this angle that I'm going to be focused on is going to be 67 degrees. So if I have this as the triangle that I'm focusing on, then all I have to do is use my sine, cosine, and tangent, and I'm going to call this side y for right now because I know that x is going to be 2 times that, because you have to keep in mind that the radius is going to intersect the chord and split it up into 2 equal pieces. So if I want to find the value of y, that is my opposite over my hypotenuse, so that is sine. So here I'm going to say the sine of 67 is equal to the opposite, which is y, over 5.25. And I'm going to multiply both sides by 5.25. So I get 5.25 times the sine of 67 is equal to y. And then once I type that into my calculator, I will end up getting that y is equal to 4.83 in 3 significant figures. And if I know that that is y, then I obviously know that x was 2 times that amount. So I can say that x is equal to 2 times y, which is 4.83. 4.83, and 2 times 4.83 will end up being 9.66. That is the value of x, and we already know that that is going to be in inches because the problem is in inches here. If you have any questions on using your trig, ratios, and shapes, please let someone know and we'll be glad to assist you. Have a great day.